Cazador de Mitos.
First of all, Professor, thank you for accepting my invitation.
Thank you for hosting me.
Yeah, you know, Chile is far, far away from the United States. So.
Oh, no, I actually visited Chile. Obviously,
great.
you have a beautiful mountain terrain, and that is extremely helpful for astronomy. And so about 12 years ago, I visited the place where we are now building the giant Magellan telescope in Chile.
That's right. That's right. Yeah, we have a lot of observatories here.
Right.
Okay, well, first of all, one of the questions that I have is, Professor Loeb, in the last decade, we have been surprised by the appearance of strange interstellar objects. And had this happened before, and what can we expect in the coming years?
Right. So only over the past decade, we discovered objects from outside the solar system that are big. I mean, obviously, before that, we noticed there are dust particles coming from interstellar space. But a large object, the size of 100 meters or more, were discovered by telescope. The first one was discovered by the Pan-STARRS telescope in Hawaii, and it was given the name Oumuamua, which means a scout in the Hawaiian language. And most recently, on July 1st, the telescope in Chile, Atlas, discovered it, and that was just a few weeks after the Rubin Observatory was inaugurated, also in Chile, supported by the National Science Foundation, Department of Energy. So this was the third one, and in between them, there was, in 2019, a discovery that was completely serendipitous by an amateur astronomer, Gennady Borisov, and that's actually the second interstellar object. Before those, there was actually a meteor that was spotted by the US government satellites, and it moved, the object was moving too fast to be bound by gravity to the sun. That was confirmed by the US Space Command. And so there was an object that collided with Earth. It was just a meter in size. But the ones detected by telescopes are three. Given this short history, we only have a limited number, just three. If you ask why, it's because we didn't have the capability to survey the sky the way we are doing now. It's partly a result of the computational abilities that we have now that were not in existence more than a decade ago. So we can process large amounts of data and discover in real time objects that are quite rare, because only 1 in 1,000 or more objects that we see are actually from interstellar space, because most of them are rocks that belong to the solar system, bound by gravity to the sun. And the way we distinguish an interstellar object is by its high speed. It moves too fast to be bound by gravity to the sun. And for example, near the Earth, that speed is 42 kilometers per second. It's square root of 2 larger than the orbital speed of the Earth around the sun. So at any point away from the sun, the escape speed, the speed needed to escape from the sun's gravity, is square root of 2 larger than a circular orbit that the planets often have. So we can tell if an object moves faster, and it's easy to understand that because when we want to launch a spacecraft out of the gravitational pull of the Earth, we need to endow it with a large enough speed. You know, if we throw a rock up, it comes down. If you throw it fast enough, it will eventually exit the gravitational pull of the Earth. So the same applies to the sun, and that's how we find interstellar objects. Now, the 2 out of the 3 that I mentioned had anomalies. Oumuamua had an extreme shape based on the fact that the amount of sunlight reflected from it changed by a factor of 10 as it was tumbling every 8 hours. And the analysis of the data implied that it's a flat object, most likely like a pancake or a disk. And then it was also pushed away from the sun by some mysterious force without showing any evidence for gas or dust around it, no evaporation that would give it the rocket effect, the way that comets often get. So it wasn't clear what its nature is. And in addition, the third object, Atlas, also has some anomalies. It could be very big. We don't know exactly what its size is, but the estimates range between a few kilometers up to several tens of kilometers. And in that case, if it's several tens of kilometers based on the reflection of sunlight, then it implies that the object is 1,000,000 times more massive than the previous two, Oumuamua and Borisov. 1,000,000 times more massive is very unusual, because you would expect 1,000,000 rocks that are smaller before you find one giant one. And also, there is not enough rocky material in interstellar space to deliver such a huge rock to our vicinity. And that the other anomaly of 3I Atlas is that it's it's aligned with the plane of the planets around the sun to within 5 degrees. And this is a very unusual fine-tuned trajectory, and the chance of that happening at random is 1 in 500. So the question,
very unusual.
Yeah, it's very unusual. So there are anomalies of both 3I Atlas and 1I. I mean, by the way, the digit means which one was first discovered. So the first one, 1I, I means interstellar. Oumuamua, that was also anomalous for different reasons. And, it's a new frontier. And for me, the fundamental question is whether among the rocks that arrive from interstellar space, there might be a tennis ball that was thrown by a neighbor, an artificial object that is not natural. And Borisov was definitely natural. Borisov was a comet.
Oh, yeah. But Professor, I believe that this is an unique opportunity for science to have the chance to study these ancient visitors. But speculating, what if they were actually a form of technology that is unrecognizable to us?
Well, that's possible. It could also be recognizable. So we first need to check. So, for example, I defined a new scale that is now called the Loeb scale. There are already several papers written about that, where 0 is a definitely natural object that looks natural. For example, a comet that has a tail and it looks like a comet. It evaporates close to the sun, made of ices that we recognize. Or an asteroid, a rock. And then 10 means a definitely technological object that could potentially pose a threat to humanity if it comes towards the Earth. And I gave a rank of 4 to both Oumuamua and as of now to 3I Atlas. Of course, the rank will change if we get better data on 3I Atlas, and it could either change to 0 or it could change to 10 if the object, for example, maneuvers in a way that cannot be explained naturally, but implies propulsion, or if the object broadcasts a signal or has artificial lights that it's not just reflecting sunlight, for example. So there are many ways. Or if we get, for example, a close-up photograph of the object and it doesn't look like a rock, it looks like a piece of technology. For example, 3I Atlas will come on October 3rd, very, very soon. It will come within 29 million kilometers from Mars. And we have a camera called HiRISE on board the Mars Reconnaissance Orbiter that is 0.5 meter in diameter, and it can resolve the object with a pixel resolution of about 30 kilometers. So if the image shows something really unusual, like a big structure, or it shows that it's not one object, but there are also accompanying objects like mini probes that accompany. So that could indicate the technological origin. It's all about data, by the way. And so these are things we can recognize. But you asked about things we don't recognize. For example, you can imagine something like a Trojan horse, where from the outside it looks completely innocent. And then in the inside of a an exterior that looks like a comet or a rock.
Mhm.
In the inside, there is some technology. We could potentially detect that as well if, for example, we detect a broadcast from the inside, or we see that there
Okay.
is a source of heat that cannot
Mhm.
be explained by illumination from sunlight.
Yeah, yeah, right, right. But anyway, I'm a little worried about it, but
No,
if
definitely. That's something to consider. By the way, another thing that I was alerted to by some people who read my essays, I write an essay every day or two on medium.com, and I got a few messages saying, it could be also deception. So you see a rock and you
Mhm.
focus on that big rock with your telescopes, but then something else is happening in the other side. We have
Oh
to
yeah.
be aware of that. So if they want if some intelligence, some other technological civilization wants to uh, us not to notice that they are coming on a reconnaissance mission, they might actually come together with a natural object on one side while they
Yeah.
are doing something else, and we
Oh
focus on
yeah.
this big thing. Yeah.
Yeah. But I know in a way you have answered this next question, but if we were ever faced with a technology far beyond our comprehension, how
Right.
could science even begin to build a framework to study it?
Yeah, that's an excellent question. And the answer is we just need to look for things that are not familiar without anticipating what they might be. But I should say the current surveys by astronomers are sensitive to the kind of speeds that rocks are moving at, of the order of tens of kilometers per second. If there was
Mhm.
an object moving very fast, I mean, 30 kilometers per second is 1 part in 10,000 of the speed of light. It's a percent of the speed of light. So if there was an object moving at a fraction of the speed of light, let's say 10% of the speed of light, or
Mhm.
even closer, it would not show up in astronomical surveys at all, because the image during the exposure of the
Mhm.
telescope, the image of this object will be smeared to a line that is very
Okay.
faint, and we wouldn't be able to actually notice it. So astronomers are looking for modest speeds that are characteristic of rocks.
Okay.
And if something is moving too fast, they wouldn't notice it. Also, if something is too small, they won't notice it. We can detect objects that are bigger than a football field right
Okay.
now within the orbit of the Earth around the sun.
Mhm.
Only if they come extremely close to Earth, we would be able to notice them from the reflection of sunlight if they are smaller. And by the way, we've never built a rocket or a spacecraft that is as big as a football field, 100
Oh
meters
yeah.
in size. So we are definitely blind even to conventional rockets that are too small for us to detect with our telescopes, or moving too
Mhm.
fast. But as you say, it could be also technologies beyond what we imagine, because
Mhm.
we have a very limited knowledge of science and technology, just 100 years old since quantum mechanics was discovered.
Oh yeah. Yeah, you're right. And well, I will return with this topic, but before that, you often advocate for a Galileo project approach to UFOs and interstellar objects. What progress has the Galileo project made in terms of concrete data collection since its inception?
Right. So we dedicated most of the time to building new observatories which monitor the sky, the entire sky at all times. Astronomical observatories are usually focused on a small portion of the sky. These are the observatories you find in Chile. And
Yeah.
what we are doing is building observatories that look at the entire sky all the time in the infrared, optical band, radio, and audio, because the kind of objects we care about can move relatively fast across the sky, since they're closer to us than in astronomy, far away objects
Mhm.
like at the edge of the universe. So um, because of that, it took us some time to construct these new architectures of observatories. And now we built three of them, one in Massachusetts, one in Pennsylvania, and the third one in Nevada. And
Mhm.
within a month, we will start really to be able to infer distances of objects in the sky, because we will have multiple units that triangulate an object, look at an object from different directions and figure out the distance. And that's extremely important, because only if you have distance, you can tell velocity or acceleration and decide whether an object is outside the performance envelope of human-made technologies. And that we will have within a month. And we are expecting to collect data on a few million objects every year, starting next month. And we will analyze the data with machine learning software so that we can tell the difference between human-made objects and natural objects, and also search for outliers. These are objects that we cannot explain, and that will be the objective. In addition to that, I also have postdocs that will work on data coming from the Rubin Observatory in Chile, because that data might also contain interesting objects near Earth or interstellar objects. And either way, if the object comes close to Earth or flies within the inner solar system, I would like to understand if there is anything other than rocks, natural objects, because, you know, we launched 5 probes to interstellar space: Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons. And we are just at the beginning of our technological era. And you can imagine that the civilization that predated us by a billion years or a few billion years, you know, they would have accomplished much more. And and we just need to approach it like the way science is, without prejudice. A lot of my colleagues are saying, yeah, there is very likely life in the form of microbes. Let's invest more than $10 billion in the next couple of decades to look for microbes. And, you know, the situation is very similar to seeing a lot of houses on the street. You say, oh, I know that my house has microbes. They must be very common. Therefore, they must exist in houses on the street. The only problem is to find them. It's really difficult, very challenging from your window to look out with telescopes and figure out that other houses on the street are, you know, have microbes. And in the context of exoplanets, you know, we know of a lot of Earth-Sun analogs. There should be billions of them in the Milky Way galaxy. But to figure out, based on the chemical fingerprints of atmospheres of planets, that they exist is very challenging. It costs more than $10 billion. And I'm saying, even if a resident in one of the houses on the street, even if that is rare relative to microbes, you know, the signatures would be very clear, because you might find a tennis ball in your backyard. The visitor might, you know, that neighbor might come and knock on your front door as a visitor. Or you might see some construction project that is easily discernible from a distance in the backyard of another house. So my point is, even though residents like us are maybe more rare than microbes, it doesn't mean that we need to spend all the money on the search for microbes. We need to hedge our bets. And I think it's common sense to do that. And because we don't know which one would be easier to detect. And the new era of interstellar objects offers us a new way of looking for life elsewhere, because it's very different from radio signals. You know, radio signals are just like waiting for a phone call. Nobody may call you from your street. You know, you can wait for a long time. But looking for packages in your mailbox or objects that arrive to your backyard is a different approach of searching for a neighbor. And that was not attempted. So now, given that we detected interstellar objects, we should embark on a new frontier. And the other thing is, even if we discover a rock that came from a neighbor's yard, if we get a sample of material from that rock, we can study it in the laboratory and look for the building blocks of life. And this is a completely different approach than looking at an exoplanet from a distance and trying to infer what happens in the atmosphere. I'm saying, let's take material from a rock that arrived from another star, because, you know, that rock spent millions to billions of years to travel to us. If we wanted to do that ourselves, we would need to travel millions or billions of years. But that rock arrived at us. So this is a completely new approach to astrobiology, which is let's retrieve some materials from these interstellar rocks and examine them in the laboratory. We did that for the Bennu the asteroid Bennu that is from the solar system in the OSIRIS-REx mission, and we found amino acids, the building blocks of life as we know it on Earth.
Wow, great! But in addition to that, or related with that, in your writings, like or as extraterrestrial, you emphasize the importance of open-minded science. Do you think academia is becoming more receptive to unconventional hypotheses, or do you still encounter resistance?
I encounter resistance. It's coming from a small group of people that are not necessarily the best scientists, I must say, and are also, I mean, they basically want to get to the limelight by criticizing me and arguing that they think differently, and frankly, they're doing this just because I think differently than the popular view right now. But science, as I told students in my class this morning, science or physics in general is very different from other items that you find in politics, for example, or in the legal system. Because first of all, the laws of physics, they cannot be violated. If you find one electron, one atom that decides to violate the laws of physics, you will get a Nobel Prize. All atoms, all electrons follow the same laws of physics. That's amazing, because humans, there are laws of society and humans can violate them easily. The second thing is, in the legal system that we are familiar with in society, what people say matters a lot. You can put a person in jail, you can put a person, on death row based on what other people say about this person. However, we know that people that were on death row were exonerated by DNA evidence, meaning that you can't trust people. In physics, you rely on instruments, on data, and it's very different from the culture that you have on social media or in science, when there are big echo chambers of quote-unquote experts that repeat the same ideas again and again. They want to preserve the dogma. And my point is that progress in physics or science is made by paying attention to anomalies, not by paying attention to what the experts or everyone else is saying, because the experts want to preserve their status, which is built on past knowledge, and they resist new knowledge. So what they often do, and this is a dirty trick that you often find in academia, first of all, they would shove all the anomalies under the carpet of traditional thinking. Let me give you an example. When you find an object that has non-gravitational acceleration, what the experts on comets would say, oh, it must be a comet because it has a rocket effect. But then you don't see any cometary evaporation. You don't see evidence for dust or gas around it. And that's what happened with Oumuamua. Then they call it dark comet, meaning it's a comet where you don't see the tail or the gas. And I say that's an oxymoron. It's just like I say the emperor has no clothes. And the adults in the room are saying, no, the emperor has clothes, you just can't see them. And this is a cheat. It's a cheat because it's just like saying an elephant, like saying all animals are zebras. So when you see an elephant, you say, oh, the elephant is a zebra without stripes. That is not intellectually honest. But that's what the experts on comets are doing. So that's one way to shove anomalies under the carpet of traditional thinking. And there are other tricks. Other tricks are to suppress publications, like serving as a referee and putting a lot of obstacles to anyone who tries to deviate from the folklore, from the common path. And it's very easy because as a referee, you have the power. So you can say, oh, this is not sufficiently quantitative. This is not. And you put a bar that is far higher than you put on conventional thinking. Conventional thinking, there are hundreds of papers that do not say anything new. They keep repeating what is already known and just adding a nuance. And the experts would be extremely happy because it makes their stature a bit bigger and better. That's what they were saying, and now it's repeated, so they would accept it immediately for publication. But if someone shows evidence that deviates from the paradigm, that would be immediately challenged, blocked, and not listened to. And then if it gets attention, these experts would ridicule it and say bad things about the people who are advocating that. And I can sort of understand where it's coming from, but the problem with that is, first, it discourages young people from innovating, because they ask, what if I need to get a job? I have to be careful not to get that kind of a negativity. But the damage beyond suppressing innovation is also that the mainstream can work for decades. For example, we don't know what most of the matter in the universe is. We call it dark matter. And when I started astrophysics 40 years ago, it was popular to think that the dark matter, the most likely dark matter candidate, is the lightest supersymmetric particle. And then, we invested $10 billion in the Large Hadron Collider at CERN. We didn't find this new symmetry of nature, supersymmetry. And so now it's clear that the parameter space that was associated with the lightest supersymmetric particle, it's ruled out. That's the natural parameter space that was proposed for decades. But that was the view of the mainstream that allowed billions of dollars to be poured in this direction. Now, I'm not saying, that was a waste, because you never know in advance. You go in the dark, you don't know what the answer is. But if you just limit all the funding to one path that is endorsed by the mainstream, like we will search for microbes and nothing else, we would ridicule the search for intelligent civilizations because that's an extraordinary claim. We might be the smartest, most accomplished civilization that ever lived. We are the pinnacle of the universe. We are the best that you can imagine. I don't think so, by the way. I read the news every day. There is a lot of room for improvement. I don't think that our intelligence is, representing the smartest kid in the class. I think there are others. But beyond this sense of cosmic modesty, you have to diversify the portfolio. You can't put everyone on the same path and say, we will put $10 billion to that and zero to the other. You can't just say that. And that's exactly where we are in terms of searching for life. It is completely acceptable by the experts to allocate more than $10 billion over the next 2 decades to the search for microbes, and zero federal funding to the search for intelligence. And I don't think that's a good approach, because you never know where the discovery will come from. You have to open up multiple paths. And, I don't think it's a sign of intelligence. I think common sense is not common in academia. And the public understands that, because the public resonates with these questions about, is there another intelligence out there?
Yeah, you're right. That's my opinion. I think you're right. You're completely right. And I have the two last questions. Looking ahead, do you believe our best chances of detecting alien technology will come from interstellar objects, from atmospheric UAP studies, or from large-scale astronomical surveys such as the Vera Rubin Observatory?
It's hard for me to forecast, but I would argue we should look at all three. And the fundamental question is whether the US government, for example, has already some information that could be interesting. I don't know, because I was never exposed to that kind of information. But we should, since we don't know which path would lead to a discovery, we should explore all of them. And, it will have a huge impact on the future of humanity if we find another civilization, because it will serve as a good role model for us. We might realize that our priorities are inappropriate. We are focusing on conflicts on this small rock that we were born on. And there is so much real estate out there that it will change our perspective. And my hope is that it will bring us, all humans, to cooperate instead of engaging in conflicts the way we see in the news every day. because we are all in the same boat. And it will also inspire us to explore space, because if someone else reached our backyard, we better get going and explore interstellar space. And especially since there are risks of staying on Earth. And by the way, going to Mars, I don't find very inspiring, because it's just another rock, and it's not a better rock than the one we are living on. It has no atmosphere. The temperature changes by hundreds of degrees between day and night. And also you are exposed to cosmic rays, energetic particles, if you stay on the surface, and you will die within a few years just from that. So why go to a place which is worse than Earth? If we want to explore space, we should build a space platform that can accommodate humans. And we moved. You might say, well, that's a huge challenge. Well, first of all, it's not a huge challenge. If we decide to allocate a fraction of the $2.4 trillion a year that we currently invest in military budgets, if we allocate that to exploration of space, we can do it by the end of this century, build a space platform on which humans can live for long periods of time and travel. But in addition to that, we started in the jungles of Africa, and we moved to high rises in cities. And to me, the transition from high rises in cities to space is less difficult, less challenging than the previous transition that we already made as humans. So let's just do it. And of course, I don't expect things to happen overnight, but I do think we need a wake-up call, which could come from the discovery of a spacecraft near Earth.
Okay, but finally, Professor, on a more personal note, what drives you to continue challenging mainstream assumptions, even when it places you at odds with much of the scientific establishment?
It's very simple. I realized that the Vatican made a mistake when they put Galileo Galilei in house arrest. He said that there are moons around Jupiter based on what he sees through his telescope, and therefore not everything is revolving around the Earth. And they said, oh, we will suppress your findings by putting you in house arrest. We don't want the public to hear about it. Instead, if they said, we have more money than you do, we will build a better telescope and collect better data that will show that you are wrong. If they were to do that, they would realize that he's correct very quickly. Now, instead, what they did is 350 years after he died, in 1992, they confessed. They said publicly that he was right. And that's a huge embarrassment for the Vatican. It's the worst in terms of public relations that they could have had. Because we already visited the moon by then, 2 decades earlier, and it would have been completely foolish for them to insist that the Earth is the center of the universe when you see the Earth from a distance moving around the sun. So my point is that having a lot of data brings you eventually to the correct view. And by the way, one way to tell the difference between a conspiracy theorist or a dogmatist and a genuine scientist is to give all of them a lot of data. The genuine scientist will be happy, even if it doesn't confirm the original view that the scientist had, because it's an opportunity to learn from the new data. But a dogmatist or a conspiracy theorist will be worried about more data because it may violate what they believe in. And the church behaved like a dogmatic institution, which was a big mistake. So here is my motivation. You asked me about my motivation. My motivation is to encourage all my colleagues to prove me wrong. Because what will happen is, by the time they collect a lot of data on all these interstellar objects to prove me wrong, if it turns out that they are not rocks, that there are some anomalies that imply that they are technological, it will not be possible for these observers to shove these anomalies under the carpet of traditional thinking, because the only way they can do that with Oumuamua is we didn't get enough data. So, the trick of people who want to maintain their view is Oh, I don't need data. I know the answer. It's a comet. Forget about it. Let's move on. I don't want that to happen. So the only way for me to encourage them to take as much data as possible is to ask them to prove me wrong. And then, if I end up being wrong, it's not such a bad thing. Okay, so one person was wrong. On the other hand, if we discover an extraterrestrial artifact that was produced by another civilization, we can learn a lot from that, and that will change the future of humanity. So this is my motivation.
Professor, thank you for your time. It's been a pleasure to talk with you, and from this faraway country called Chile, really honored, and I appreciate your time.
Thank you so much for inviting me. I had a wonderful time in Chile when I visited there, and I look forward to my next visit.
Cazador de Mitos.